Hello. Yeah, good morning. Very pleased to be here. Very well-organized summit from the Celestia folks. My name is Anurag, and I'm going to talk about Avail architecture today. Can I have the next slide, please? How do I? Yeah. So just to provide some context on what Avail is, right? Like, I mean, uh, so Avail was started within Polygon in November 2020, and we recently spun Avail out in March 2023 to become a completely separate independent entity. What Avail is a data availability layer which uses a combination of erasure coding, KZG polynomial commitments, and data availability sampling. And essentially, and I'll provide some context on where we are in that. Some of my background is I previously founded Polygon in 2017, and because I started the project with my co-founder Prabal in 2020, and we just spun it out just very recently. So the entire team of Polygon came over to join us at Avail. So that's some of the background, and you can see some of the history here. So today, like a lot of people, ask me on Twitter regarding the architecture, and so that's why I wanted to focus on what Avail is, what are the use cases, and so I'll try to get a bit into the technical details as much as possible within the short time window. So before I get into the meat of the presentation, right, like some context. I know this is a Modular Summit audience, and so in general, no major introduction required, but essentially what I want to talk is that rollups are now acknowledged to be the main way to do off-chain execution. And if you can see the rise of Ethereum rollups, right, like all the big activity is happening on layers like Polygon, zk-EVM, or Arbitrum and Optimism. And so the rollup is now considered as the best way to do off-chain execution. But if we consider that the rollup is the way to go, and blockchain constructions are becoming more and more modular with the rise of rollups. Now, it is important to see what these rollups really want and what are they hungry for. And the answer is that they really want lots of DA or data availability. And that's kind of the primary reason why we are working on Avail. And I want to make a bold statement here, in the sense that every base layer blockchain in the future is going to be a DA layer. Even Ethereum has already pivoted to a rollup-centric roadmap, and it is pivoting to a DA layer. If you've heard of danksharding, all of this point to the fact that the base layer is going to be a DA layer, and that all the execution is going to move to the rollups on top. And that is the context in which you should view Avail, that Avail is a base layer that provides scalable data availability for rollups. Now, what is Avail? This is a Celestia. This is the Modular Summit, and Celestia is one of the organizers, and so you'll ask, what are the differences between Avail and Celestia, and I'll get into that. But essentially, Avail is a modular layer that focuses on data availability. It does not do any execution. It accepts transactions from rollups and makes them available via a combination of erasure coding and KZG polynomial commitments. And in a sense, what it does is it kind of orders the transactions that come to it and provides it to the light client network. In general, the mental model for looking at Avail is very similar to what an Ethereum layer provides to the rollups on top. So in that case, the rollups do the execution on layer 2, and then there's the base layer that does the data availability. And so you can have a variety of rollup execution environments. So this includes something like the EVM, but also more complex environments like SVM, but also app-specific chains. And how we do it is a combination of erasure coding, KZG polynomial commitments, and the USP of data availability sampling, which allows downloading of block data within a few random samples. And we'll get into how that gets done. But in general, a variety of rollups can leverage this capability. This is the base layer architecture. And in general, if you look at it, right, like I'll just go through it in a little bit of detail. So what is happening is the primary consumers of Avail are rollups. Rollups accept transactions and basically submit transactions directly to Avail. We have this concept of application ID, where each rollup corresponds to a particular application ID. And then they can submit that onto the same base layer so that we can have multiple rollups submitting data to Avail, demarcated by application ID. What we then do is kind of extend the data or erasure code the data. So if you see this diagram, so the original data is then extended in general via erasure coding. And then what we do is primarily create commitments of the data. So, I mean, if you see this slide, so this is the rough structure of the blocks, right? Like, so if you see the original data, the data from the rollups is packaged into the block, and we create polynomial KZG polynomial commitments for the data, and it's erasure coded in such a way, and the homomorphic property of KZG allows us to mirror the erasure coding in the of the encoded data on the commitments as well. So if you see on the right-hand side, the C1 to Cn are the commitments of the original data, and because of the homomorphic property of the KZG commitments, like we are able to kind of extend that to the erasure coded data as well. And so once that happens, so how do I go back? This one? Yeah. OK. In general, we are able to adjust the matrix size. So what we really create, as I told you, is like an M cross N matrix. It is erasure coded to create, in general, we double the data in general. And what we then do is take the commitment and put into the header. So the header has all the commitments to the data. It also has the app index and certain other meta information. Now, this block data is then propagated to all the other validators. And basically, each validator at the moment in the current implementation regenerates those commitments and comes to consensus on the block. So that's how the base layer works. And we've already gone through the block production stack. In general, we've used Substrate to build the validator node. And the consensus that we use on the network is Grandpa and Babe. So Babe is the block production mechanism. And we have Grandpa as the finality gadget. So it's a hybrid ledger in that sense. And protects against large number of roads crashing, etc. The incentive mechanism is nominated proof of stake. Why we chose that is basically because it allows for wide stake distribution. And so what happens in nominated proof of stake is that you do not delegate to a single validator. You delegate or nominate to a pool, which then is fairly distributed to a large number of validators. So you can do a ranked choice of validators. And so essentially, why this is important is it allows us to have a pretty decentralized set of validators. And we can have up to 1,000 validators in the validator set. That's what we get from using Substrate. We use Substrate, but of course it's a data availability layer, so there's no execution. So we've disabled all the runtimes and such, and so it's a very light runtime on the base layer itself. Now, the beauty of this whole construction is we are able to do a pretty neat light line network. And in general, once the blocks are finalized and the headers are propagated to the light lines, even if a validator withholds the data, the light line networks, like basically because they can sample the block pretty efficiently, they can come to know if there's some withholding of data possible. And in general, we want to target like a large number of light lines, but in the sense a few hundred or 1,000 nodes are pretty much enough to kind of sample the block data pretty quickly. To get into the light line architecture a little bit, right? So we started with a different implementation initially, but then we had to kind of build the light line node from scratch. We use a Kademlia DHT implementation, distributed hash table implementation. And so the LCs basically form an overlay P2P network on top of the base layer. Initially, they use the full node for the bootstrapping, but over time, when you have a number of light lines on network, a new light line that enters the network essentially can start sampling from the light line. So within the light line network, there's a P2P network as well as a DHT. And so, I mean, you can think of this from a mental model. The light line network almost is like a torrent-like network. It's not the same, but you can think of it like that because it stores some of the sample data locally as well for a period of time. How we do the proof verification is that we generate cell level proofs. So as I mentioned, we have this M cross N matrix, and so depending upon the size, we'll have these proofs generated on the cell level, and so that's why there'll be a random sampling from these light lines, and they are able to verify these cell level proofs. And as I said, within a few samples, or if we have like a few hundreds or even 1,000 light lines, the entire block gets verified. And of course, there's this property that the larger the number of light lines in the network, we can increase the size of the blocks as well, like in that sense. And I will say, from an engineering effort perspective, bulk of the work that has gone into building Avail, and so we've been building this for more than 2.5 years now. First within Polygon, but now as a separate entity. And most of the work is on, the bulk of the effort is on the Lightline P2P, because there are a number of issues that, performance, etc., that have to be looked into there. This is sort of a visual representation of the data matrix that I talked about. We can play around with the number of rows, the number of columns, and you can see a reference benchmark on our performance, in the sense that if we have, if you see the table on the right, there can be for a 2 MB block size, right? The rows and columns are such, and the times to generate the commitments, the polynomial commitments, are pretty neat. And even if we increase the block size to a 32 MB or a 128 MB, you can see that these are well within our target block time, which we've at the moment kept as 20 seconds for now. And this allows for propagation across the network as well as verification of the commitments as well. Okay, so I will have time for Q&A after the session. But so in general, if you have any questions on the architecture, happy to answer post the talk. But having said that, once we've arrived at this whole construction, what is the ecosystem that we are envisioning that will be built on Avail? So as I said, this is a roll-up-centric blockchain, right? Our primary customers are roll-up developers, infrastructure developers. And so these are the different kinds of solutions that we are kind of looking at, right? So sovereign rollups, validiums, optimistic chains, and app-specific chains, right? I think Cosmos-style app chains, but more in the validity proof or optimistic construction manner. And of course, general purpose rollups as well. And recently, I mean, so the way we are thinking about this go-to-market, and I'll get into that a little bit, is that there's been a lot of activity on the L3 area. So a lot of the L2s, all the major Ethereum L2s are now looking at their own L3 initiatives. So if you look at something like an Arbitrum Orbit or a ZK Sync Hyperchain or a Polygon 2.0, or Starkwest fractal scaling strategy or Optimism superchain strategy. And so they are basically optimizing for a lot of L3s. In general, because what they want is to optimize the L2 as a liquidity hub for all the L3s on top. So that's why you'll see in the coming days a lot of one-click L3 deployment stacks. Now, why am I talking about this? Is basically because when we talk about L3s on Ethereum, right? Like the first thing that they need is a DA layer to do, like dump their for the data availability needs, and they cannot use Ethereum for that perspective. And so this is sort of the graphical representation of, like how Avail will be used in conjunction with these L2s. And we are starting to work with a number of these to come up with these constructions. We also released the Avail attestation bridge recently. It's a pretty interesting construction in the sense that there is a data attestation bridge between the Avail base layer to Ethereum. Right now, of course, it's on testnet. For now, we are doing an optimistic style construction of the bridge, but we've also been working on a ZK Snark-based data attestation bridge with our partners at Succinct. In fact, we just shot a whiteboard session on the construction. It's pretty neat. And so we are going to be working with Succinct in general to create this bi-directional bridge between Avail and Ethereum, because Succinct, if you know, already has a telepathy bridge which proves Ethereum's proof of consensus, and now we have with them, like a ZK Snark-based construction which proves Avail's proof of consensus, which is Grandpa Babe. So that's one focus area that we are going to work with. And of course, we are going to work with Sovereign Labs in that, Sovereign rollups in that sense, in the sense that current rollups are primarily implemented as, to be verified on a smart contract on the Ethereum base layer. But with our data availability sampling light lines, what is also possible, and especially with ZK constructions and recursive proof mechanisms, we are also able to kind of propagate these proofs to the light line layer. And in fact, we are also talking with a bunch of wallet teams in general to kind of embed the light line into the wallet itself, right? Like, I mean, right now, light lines are run via desktop apps or CLI or something like that. But what we envision is eventually they will make their way to wallets. And so very similar to, like, let's say Bitcoin light lines or such, right? Like where the user doesn't even know that the light client is working in the background. And why we are able to make this possible is basically because of the lightweight construction in which these light lines can actually even work on mobile devices and hopefully in the browser and such at some point in time. And so we envision that there will be a lot of light clients. And essentially, I mean, this is an underrated development, but today, like to verify, for a user to verify the state of the blockchain, it's not that straightforward on today's blockchains. And what we will enable with this combination of DA light clients plus recursive ZK proofs is that any user will be able to verify the state of the blockchain pretty easily. And as I said, modular base layers are perfect for sovereign rollups. And along with us, of course, Celestia is also taking up the mantle. And so we are very happy to grow the ecosystem together. I'll quickly end with like the development stage and timelines. As I said, we have been in development since 2.5 years. Currently on our second long-running testnet, which is we call it the Kate testnet. It's named after Aniket Kate, who was one of the researchers behind the KZG polynomial commitment. We already have a robust set of external validators already on the testnet, and we are targeting 200 next month, I guess. And we want to do an incentivized testnet, which we want to scale to a 5,000 light client number pretty quickly. We'll have an incentivized testnet also this quarter. And the mainnet target is end of Q4 or early Q1. That's the mainnet target for now. We are pretty comfortable in terms of where we are in terms of development. Quickly getting to the optimizations. So currently in our base layer, what happens is when the block producer creates proposes the block, creates the commitments, we propagate this to other validators and they regenerate the commitments at their end. What we want to move to a construction in the future is a construction where other validators can just verify the commitments and not regenerate them, which will make it much faster for to arrive at finality and such. We are also working on a very neat construction called KZG multiproof. So if you remember the matrix that we create these proofs at the cell level. And so what we want to do is do sub-matrix level openings. And so, we kind of reduce the complexity of verification pretty significantly. And this will, create huge improvements in terms of, the opening generation, the DST population, and, overall keeping the network streams, manageable. And of course, while ensuring backward compatibility. And as I said a little bit earlier, we are working on this ZK snark-based data attestation bridge. And this is a pretty neat construction where, we are able to prove Avail proof of consensus, which is Grandpa Babe consensus, within the snark circuit. And I think this will be pretty useful for deploying or connecting our chain to a variety of other ecosystems because of the nature of the bridge itself. Yeah, I think I've wanted to cover whatever I wanted. These are some of the links, important links. Please feel free to scan the QR code. We'll have this presentation available online as well. And generally, yes, we are hiring across the board. When we started 3 months ago, we were at 18. Now we are at 27, and so we are looking for quality folks to join the team. And so, if you're looking for to join a growing team, please feel free to ping us. And this is also our Twitter handle. So, looking forward to talk to some of you. And of course, I'm available, and a lot of our team is also available in the event. And happy to talk to you as well. Yeah, thank you.